Hello everyone, so in this video I just want to go over the wave generator and oscilloscope tools in waveforms and how we're going to be using it for this lab. So going straight to wave generator, we have this window, and here we have several options we can set for our waveform. So there are different types of waveforms. We have the sine wave by clicking on the drop down, square, triangle, ramp up, ramp down, pulse, trapezium, and sine power. So this is the square wave, triangle, and ramp up, and the other ones can be seen. So for this video, I'm just going to be going over the sine wave, and you can see I can either select the frequency by clicking on the drop down and selecting which one I want. Because we have the BNC adapter and oscilloscope probes, our wave generator does go up to 25 megahertz. So I'm just going to go ahead and select a 5 kilohertz waveform. Another way to select a waveform is by entering the value manually. So I'm going to put 6.35 kilohertz. As you can see, it changes. As you can see, also the horizontal and the vertical do change accordingly to the frequency that I set for the waveform. So as I set the frequency to 6.35 kilohertz, the period adjusted to that specific frequency to show one cycle on the display. If I showed, let's say I select 10 kilohertz, you can see that also the display changes so that it shows one period of 10 kilohertz signal, and the period is adjusted here as well. And likewise, I can do the same thing for period, and the frequency will change accordingly. So if I do 500 microseconds of a period and push enter, then the frequency will change accordingly. On this section where it says amplitude, we can set the amplitude for our signal. As you can see on this graph here, we have units of 1. So this line will represent 1, 2, 3, 4. And likewise for the negative side, 0, -1, -2, -3. We have set the amplitude for this signal to have 3 volts. Therefore, at the maximum, it will have 3 volts. And the minimum should be 3 volts as well. We can change the amplitudes to range from 5 to -5. Or even smaller values. Now, when changing to a smaller value, for instance, millivolts, the vertical axis changes the units as well. So you can see here we have the scale is now at 5 volts per line with the unit number of millivolts. So 5 millivolts, 10 millivolts, 15 millivolts, 20 millivolts. We have a DC offset option, which we can offset the signal by a DC voltage. We can change the symmetry, and we can shift the signal by a certain amount. So if I shift the signal by the sine wave by 45 degrees, you can see that no longer at 0 microseconds, it no longer starts at 0, it starts at another value. Although this might not be necessary for our labs, I just want to demonstrate to you what is possible to do with our wave generator. Now currently I do have the BNC adapter connected to my analog discovery 2. I have my signal cable connected to the W1 terminal on the BNC adapter, and I do have the oscilloscope probe connected to channel 1 terminal on the BNC adapter as well, with the oscilloscope probe connected to the red alligator clip and the ground probe of the oscilloscope connected to the black alligator clip of the signal cable. So now I'm going to go to my scope. So you can see the scope. It has a huge amount of display with a lot of options. So some of the main features we use in the oscilloscope is single run. Run mode is always set to repeated. Trigger is usually set to auto, but if we need a more stable reading, we go to normal. The source where we're getting the signal from is usually channel 1, or depending on you have it on channel 2, you select channel 2. The condition we'd like to trigger is on rising edge and DC voltage offset or level. Some of the features here, you see there's many of them. The main ones we are concerned with is measurements, XY cursors, X and Y cursors, and perhaps notes if needed. As you can see on the right hand side, we have a time scale where we can change the time. We have it set to 0 position where this triangle is located. You can see this center dotted line is at 0 microseconds, which each with the horizontal timescale set to 1 millisecond per division. Each line of these represented here is called a division. So if we're on a scale of 1 millisecond per division, it means that once we move over one division, we are at 1 millisecond. If we move one over, it's at 2 milliseconds, and 3 and 4, and so on. And as you can see, there's many lines on per division, which is basically the 10th of that division. So this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0 in a whole division. So this larger line right here in the center represents 0.5 milliseconds. Now this scale does change accordingly to which base value you have it as. So if I change this to 10 milliseconds per division, you can see the scale changes. Now it's at 0 milliseconds at the center, and one division over, it's 10 milliseconds, 20 milliseconds, 30, 40. And these lines represent a 10th of that division. So 1 millisecond, 2 millisecond, 3 millisecond, 4, 5 milliseconds, 6, 7, 8, 9, 10. Now same thing cannot be applied to the vertical scale. But moving forward with the time scale, I can also change my position of where I want to start off. So right now I'm centered at 0 milliseconds, but suppose I want to shift over by 10 milliseconds. But I do have to keep in mind of the metric prefix I am setting this position to. So I can't forget to put the M there. Waveforms already understands letters for metric prefixes. So I'll just go ahead and put the M in front of the S for milliseconds, and I'll push enter. And as you can see now, the center line now begins at 10 milliseconds. The next division is 20 milliseconds. Next division is 30 milliseconds. But to the left of 10 milliseconds is 0 milliseconds. And as you can see here, I have this cursor which I can move from left to right to change my position. I'm just going to go ahead and move it back to 0 milliseconds. And as I moved it back, you can see now it is at 0 milliseconds, with the position now set at 0 again by moving the cursor. As mentioned before, the same thing can be applied to the vertical positions. I can go ahead and change the scale. So right now it's set to 500 milliseconds per division. So 500 millivolts per division. So you can see here it's 0 0.5, 1, 1.5, 2, 2.5. Also on the negative side. I can change these by either selecting the value on the drop-down. So now I set it to 2 volts per division. So it's no longer in the milli range. Now it's in the volts range. And you can see that each division is now 2. So 2 volts, 4 volts, 6 volts in increments of 2. Now suppose I change this to 1 volt per division. And just like we had in the horizontal scale, we have a tenths of the divisions per division. So although it's very small to see, but you can see the small lines on the vertical scale, which represent 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. I can also offset the vertical position by a certain amount. However, this may not be needed for any experiment. As you can see, the each adjustment to the vertical scale, there's two, one for each channel, channel 1 and channel 2. Channel 1 is set to 1 volt per division, while channel 2 is set for 500 millivolts per division. By clicking on these check marks, I can select which channel I want to see, or turn off or turn on. If I go ahead and click this check mark, I can remove channel 1 from my scope. Now the letters on the vertical axis have changed from yellow to blue and now say channel C2, and the measuring units is volts. Channel 2 volts in blue letters in the same color as this border around the channel 2 settings. And likewise, just as I have I can change the scale units on the vertical scale, it will identify what are the scale units at the very top next to the channel 2. By clicking on these C1 and C2, I can interchange between which channel I would like to see. But both channels will be present if I have both of these on. For this case, I would just work with channel 1. Now that I understand the basics of the oscilloscope, I'm just going to go ahead and run a waveform. I already have my waveform here, but I'm going to change it to 10 kilohertz. A 10 kilohertz sine wave with a 100 microsecond period at a 1 volt amplitude. I'll go ahead and click run. Now go over to my scope and select run. Obviously, you'll see that the scope is not displaying one full cycle of the sine wave that we just selected in our wave generator. We have to be aware of what horizontal scale and amplitudinal scale we must set our oscilloscope in order to get a correct display of our signal. This is known. We must know what we're measuring in order to see what we want to measure. So I'm going to go ahead and I'm going to change this to 10 microseconds. So I'm going to change the prefix from milli to micro. And I represent micro with a U. So the base value is now 10 microseconds per division with the position at 0. And as you can see, I have one full cycle displayed on my oscilloscope screen. Now you may wonder, I had a 100 microsecond period for this 10 kilohertz frequency, but then when I entered the base value for my oscilloscope, I entered 10 microseconds per division. The reason I entered 10 microseconds per division is because I know that each division will be, well, first of all, there's 10 divisions. There's 5 on this side and 5 on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 in total. So if my period is 100 microseconds, and if I set my base to 10 microseconds, then I have a total of 100 microseconds across my display. Now I can also adjust the amplitude display or the scale. So if I wanted to make this larger, as you can see that it is kind of small, or uh, only using one division. If I wanted to make it use more divisions to appear larger, I would have to adjust the vertical scale like this. Because now it uses 2 divisions, because each division is now 500 millivolts. 2 divisions of 500 millivolts is 1 volt. And I can do the same thing. So to take half of that, let's do 250 millivolts. I am now using 4 divisions to represent 1 volt. We adjust these divisions, the range of the range or the values per division to manipulate the display of our signal. The next thing I'd like to show you, now that I showed you how to arrange signals on the oscilloscope using these time and channel vertical settings, now I'd like to show you how to make measurements. These measurements are already provided by the Analog Discovery 2. So if we go ahead and click on measurements on this top bar, you can see it says add, remove, edit, show, and a gearbox. So I'm just going to go select add, and we're going to go to define measurements, and see we can select channel 1 or channel 2 depending on where we'd like to add measurements on which channel. So in this case we're working on channel 1, so I'm going to select channel 1, and then there's vertical and horizontal measurements. So if I expand vertical, you can see there's measurements for maximum, minimum, average, peak to peak, high, low, middle, amplitude, AC, RMS, DC, RMS, overshoot, rise, overshoot, and fall, overshoot. So if I wanted to make measurements for the vertical positions, I can just go ahead and click on maximum. I highlight it, and then click add. If I wanted minimum, I would highlight it and click add for average and peak. I'm going to go ahead and close this now, and you can see that it labels where the words get to which channel it's applying this measurement, the name of the measurement, and the value. And as you can see, it's constantly changing values because we're continuously gathering data or sampling data from our oscilloscope tool. Now, if we wanted to get stable values, we would just do one single run. And as you can see, with a single run, it gathers a set of data or data acquisition from the signal. So as you can see, we will get different values every time we click every time we click single run. So at this point, the measured value for maximum was 0.9917 volts. The minimum is negative 1.00035 volts. The average is negative 3.65.863, which the average should be 0 because half of the cycle is positive, half of the cycle is negative. The same amplitude, therefore it should be very close to 0. Peak to peak is almost 2 volts, or 1.9995 volts. That is from here to here. Now if we wanted to remove these, I can highlight them all or highlight whichever one I would like to remove and click delete on my keyboard. Now I can also add other measurements for horizontals. So I can select frequency, just go ahead and click that, period, and add, close it, and do a single run. Why is it? Let me try one more time. Horizontal, cycles, frequency, period. I'll go ahead and select run. For some reason, Waveforms is having a hard time displaying it. Let me try one more time while the program is actually running, or the signal is actually. Anyways, in any case, the values will appear here, and it will would calculate or measure the correct frequency or the period for the given signal. Moving forward, we do have other tools that we use normally on a regular oscilloscope. One of these tools are X and Y cursors. X and Y cursors allow us to make simple comparisons between waveforms or take basic measurements if we do not want to use the measurements tool. It gives us a good idea of what we'd like to see or points we'd like to measure. So for example, we can use the X cursor, which are located at the corner of the oscilloscope tool, or the Y cursor on the other corner of the oscilloscope tool. So starting with the X cursor, I can set a cursor to any position. I can move it to one point. And as you can see, when I highlight the cursor, it tells me channel 1 of the S, where at this point where the cursor intersects the signal, I have an amplitude of negative 5.04 millivolts. With the X position or the time position at negative 30.845 nanoseconds. So I'm going to set my cursor there, and by clicking on the drop down of this cursor, I can change the position manually. So I set it to 0 seconds. It has reference to none. I'll explain why it has reference option. And I can also change the color. I'm going to change the color to blue. So now I'm going to select another cursor, and I'm going to move it to another position. Let's say the height of, or the maximum. So you can see at the somewhere around this maximum, I have 997.5 millivolts, almost 1 volt. And the position is at X, it says X2 delta 1. That is saying the change of cursor 2 with respect to 1. It is 25.262 microseconds. And again, I can set it to any desired position if needed. 25 microseconds, which is a quarter of the cycle, quarter of the period. And I can change the color. But as you can see, the reference point is this measurement. This cursor is giving measurements or deltas with reference to cursor 1. Other options I can do with these cursors is add a label to them, measure vertical or horizontal or free, change the color, change the width of the cursor, and so on. Now if I add a third cursor, I can go ahead, let's say let's put it right here. It gives me the amplitude when the cursor intersects the signal and the location. So in this case I'm just going to put negative 25 because that's a quarter of the period. And I can change the color if I wanted to. Oh, I think I clicked remove. So the same thing can be done with vertical vertical cursors. I can add multiple cursors to give rough estimations or rough comparisons between signals. And by changing the labels or changing the positions, I can have a more precise visual of comparison between signals. The way to remove these cursors is just go ahead and click on them and press delete. One more thing I'd like to add is that when using the time scale, as you can see, I've clearly displayed one cycle by using 10 microseconds per division. But suppose I want to show 2 cycles, then I should double this the time. I should double the time here. So right here across right now on my time axis or my horizontal axis, I have 100 microseconds because each division is 10 microseconds. But if I double it to 20 microseconds, 20 microseconds, as you can see now each division is 20 microseconds there, and I have 10 divisions, then I have 200 microseconds across my display, my oscilloscope display, and therefore I have 2 cycles presented on my screen. And manipulating the time base or the range is how we can show however we desire to show our signal is how we manipulate it. Well, that completes the tutorial for today. And if you have any questions, go ahead and email us or Dr. Kamali, and we can answer your questions regarding waveforms. Thank you.